So let's quickly go to the second example that we have here. Example 1b. The question says we should find x if 13xy equals 78. Okay, this is a little bit different from the first example, in the sense that in the first example we have just one variable x, but in this second example we have more than one variable. The one we are looking for, x inclusive, but the other one, y. And another thing that is important we need to know that is that the both variables in this equation are together in a term. So let me quickly digress a little. What does term mean what do I mean by a term in mathematics? In mathematics, terms are separated in an equation by the plus and the minus sign. Okay, so in this question as well as the first one, there are just two terms. The first term is 7x. Now there is no plus or minus here because there is just one on the first side and there is just one also on the second side. So in mathematics, just know that they are separated by plus or minus. So this one means 7 times x. So 7 is not a term on its own, and x is not also a term on its own. They both are one term together. So 56 is also a term. So here 13xy, no signs like plus or minus in between them. Say they are together. 13xy, it actually means 13 times x times y. So this is a term and this is also a term. So remember, to apply the principle divide both sides, you must ascertain that the term that has the variable you are looking for must be on one side of the equation and every other term must be on the other side of the equation. Okay, so in this case, that is also satisfied. We are looking for the variable x, and the term containing that variable x is 13xy. So it is alone on one side of the equation, and every other term, in this case just one, is on the other side of the equation, despite the fact that it's not the only variable there. So it's still applicable here. So we divide both sides, by what here? In the first example, we divided both sides by 7 because 7 is the coefficient of x in this example 1a. So the coefficient of x in this second example 1b will be 13y. So I said the other time that, okay, let me put it also in this way for better understanding. Permit me to use this English. The coefficient of a variable is that thing that is disturbing the variable you are looking for. So in the previous one we have just 7, but in this case we have 13y. So we divide both sides by 13y. 13y is that thing that is disturbing us from getting the value of our variable x. So the first side of the equation we have 13xy, and the second side of the equation we have 78. So the first side, 13xy, will be divided by 13y, and the second side also will be divided by 13y. 13 here 1, 13 here 1. Y here 1, y here 1. Okay, so 13 can go in 78 6 times. 13 here 1, 13 here 6. Okay, there is nothing else to call. So our answer, therefore, x equals 6y, 6 over y. So therefore, x equals 6 over y. So let's quickly go to this third example, example 1c. So the question says find m if 2x plus 9 equals 5m. 2x plus 9 equals 5m. Okay, still on the same note, we have to know if we can apply the principle divide both sides, and by what should we divide both sides. So the first thing I told us that must be ascertained before this principle can be used, can be applied, is that the term containing the variable we are looking for, m, variable m in this case, must be on one side of the equation and every other term must be on the other side of the equation. Note my words, I didn't say it must be on the left hand side of the equation, because you note in this case, the term containing the variable we are looking for is the term 5m. 9 is a term, 2x is also a term. Now 5m, which is the term containing the variable m we are looking for, is on the right hand side of the equation, unlike the two previous ones we solved. The term we are looking, the variable we are looking for, the term containing that variable is on the left hand side. So note that it's not compulsory that it must be on the left hand side. So far it is alone on one side, either the left or the right, then you can apply it. And every other term must be on the other side of the equation. So can we actually apply this principle here? Yes, we could. Why? Because the term 5m containing the variable m we are looking for is alone on one side of the equation, in this case though on the right hand side, but that doesn't change anything. And every other term, term 9 and then term 2x, they are on the other side of the equation, which is the left hand side of the equation, and therefore we could. So okay, before I do that, I was saying one thing or the other time that terms in mathematics are separated by the plus sign or the minus sign. So there are three terms here. 2 is not a term on its own, x is not a term on its own. Both are one term, 2x. So separated from 9 by the sign plus. So plus, this is another term, then this is another term. There are three terms in this equation. So we divide both sides, by divide both sides by what? The coefficient of the variable we are looking for, which is 5. So the first side we have 2x plus 9, and the second side we have 5m. So the first side will be divided by 5, and the second side also divided by 5. Okay? So there's nothing to cut here, because there's nothing that can go both in the numerator and the denominator of this fraction. So there's nothing to cut here. 5 cannot go in 2x, 5 cannot go in 9. And even, let's say, instead of 9, it is 10 that is here. Some funny students would say 5 year 1, 5 year 2. That is very wrong mathematically. Why is it wrong? It is wrong because this 5 not only belongs to 10, it belongs to both 2x and 10. Is that clear? So if it is just 10 all over 5, you can cut 5 year 1, 5 year 2. But we have here 2x plus 10 all over 5. So you can't cut 5 with 10 alone. That would be very wrong. Okay? A scenario may occur where you can actually use 5 to cut a numerator of this type. An example is, suppose we have suppose we have 10x plus 20 all over 5. Yeah. So you can use 5 to cut the numerator. Why and how? So what you do first is you factorize these. You notice that there is something common to the first term of this numerator and the second one, and 10 is that number that is common to them. So you bring that 10 out. So if you take 10 out of these, 10x divided by 10, it remains x, plus 20 divided by 10, that's 2. So that's how to factorize, then all over 5. Now this means 10 multiplied by x plus 2. X plus 2 together multiplied by 10. So it is not separated by plus or minus. So you can cut. So 5 here 1, 5 here 2. And you finally have 2 into bracket x plus 2. And also you can open the bracket by saying 2x plus 4. Okay, so that's about that. Now let's go back to the exact question we have. So what led us to this is, if we could, if supposing this is 10, if we could cut 5 with 10 alone. No, you can't. You can only do that if there is a factor of both terms here, then you bring it out, then you cut. If that factor is also a multiple of 5, so then you cut. But in this case, we have 9. And even if we have 10, remember we can't cut. Okay? So we have 9. So there's nothing to cut here. So, but we can cut 5 here. 5 here 1, 5 here 1. So we have 2x plus 9 all over 5 equals m. Okay? Some may think this looks somehow. It should be m equals something. Of course, we can write it in that way too. And why can we write it that way? The reason being that in mathematics, when you say A equals B, it also means that B equals A. So if 2x plus 9 all over 5 equals m, therefore m is also equals 2x plus 9 over 5. And that's the final answer. These and these are actually the same. So that's the end of the solution to question example 1.